T-minus 40 seconds. Everything looks good for launch.
Have you ever fantasized about going somewhere special? Somewhere far from crowds? Off the beaten track? Somewhere out of this world? Is it time to catch a rocket to the Red Planet?
Mars is filled with mysteries. Volcanoes 75,000 feet tall. Huge canyons, 3,000 miles across and 6 miles deep. All kinds of interesting features.
Awaiting you is some of the greatest scenery in our solar system. On a world where water once ruled, then vanished into thin air, where lost microbe empires may still survive underground. We've seen the postcards, and we do wish we were there.
Just the thought of being in this new world, seeing a landscape that no other person had seen before, I think there are a lot of astronauts that would sign up to that.
Go with power.
But don't be fooled. Nothing about going to Mars will be easy. Danger awaits you on this desolate beauty, and perhaps Martians too.
If we find on Mars evidence of a second independent origin of life, that's hugely profound because it tells us right away that life is common in the universe.
Mars, invaded by a robot, and perhaps soon by an Earthling like you.
Would I like to go to Mars? Oh, in a heartbeat. Absolutely. If there was any way for me to be going to Mars, I wouldn't be screwing around with robots. You know, I'd want to go myself.
There has never been a better time to boldly go where no human has gone before. To follow in the footsteps of our robot pioneers and visit the planets of the solar system. It's been said that the first person on Mars is alive somewhere on Earth today. Imagine it's you. What do you need to know? How might you get there, and what should you pack? What are some of the must-see sites, and what should you avoid? Think of this as your personal travel guide to exploring the Red Planet. Mars has always had a mystique. It's one of the easier planets to spot in the night sky. A constant dot of red light moving through the heavens. And now we know for sure that of all the planets, this red, rocky one is the most similar to home. Here are polar caps and sun-baked deserts, giant volcanoes and mighty canyons. Mars even spins at about the same speed as Earth, making a Martian day only about 40 minutes longer than ours. Although it's further out from the sun and takes twice as long to circle it, the long Martian year has identifiable seasons. And what's more, our two planets share a common childhood.
In many ways, it's a sister of the Earth. It was formed at roughly the same time, about 4.5 billion years ago, with a little change here and there. It also was formed of the same sorts of materials, bombarded by comets and asteroids. So it has the same delivery system we have.
Could life have been forged in the same way on both planets? When we sent the first probes to investigate in the 1960s, almost anything was possible.
Originally, in the popular imagination, we thought that Mars might be inhabited by whole civilizations, building canals and so on. And then the Mariner flyby missions really painted a very grim black and white view of Mars as being barren.
The pictures and data recorded by Mariner 4 revealed Mars to be a cold, barren planet.
Should be coming up on terminal 10 ignition.
SCS is close to vertical.
Still, NASA was eager to look for signs of life. In 1976, the Viking spacecraft arrives from Earth for our first close encounter. And there are still hopes of a welcoming committee. But both Viking spacecraft send back photos of nothing but rocks and sand.
We had cameras, so obviously if there was a yucca plant or I was hoping there'd be a freeway in the distance, but what the main thrust of Viking was actually was some chemical laboratories, and they looked for the chemical signs of life.
Even the dirt seems devoid of life.
There was always a chance that when they were so busy looking for microbes, there could be a large organism looking over their shoulder that they completely missed. But now we have enormous amount of imagery that shows nothing like a large organism. There are no cats running around, there are no bisons, there are no palm trees.
It seems Mars is not the kind of planet that gives up its secrets easily. But if you dig a little deeper, you soon find that this is a world worthy of a closer look. There are some basic things you should know about Mars before leaving home. Most days will be clear and sunny and cold. The average temperature on Mars is as bitter as midwinter in Antarctica. At about half the diameter of the Earth, Mars is a handy size, but it's much less dense than Earth, with about a third of the gravity. Surprisingly, the actual surface area is almost exactly the same as all the dry land on Earth, shrunk together without the oceans. Build a few freeways and you could drive around Mars in a couple of weeks. And driving around Mars is exactly what planetary scientist Steve Squires has been doing since 2004. Not in person, but via NASA's two off-road robot rovers, Spirit and Opportunity.
Stand by. This time we are 5 minutes, 55 seconds after entry. Looks like nothing I've ever seen before in my life.
For all of us here on Earth, the snapshots sent back by these forward scouts are the next best thing to standing on Mars in a spacesuit.
We very consciously gave these robots some human-like qualities. The cameras are about this high off the ground. They're the same height as human eyes. It's the visual experience that you get from looking at the rover's pictures is intentionally like what you would get if you were looking at the visor of your helmet in a spacesuit on Mars. I really think that if you put somebody on my team who's been part of this mission for so long down at Eagle Crater or on the summit of Husband Hill, you'd look around and you'd say, yeah, that's about right. That's what I expected.
In the 4 decades since our robots first arrived, the once fuzzy ball at the end of our telescopes has steadily focused into a red planet we can understand. And it's not a welcoming place. The problem is the atmosphere is so thin and cold that water exists only as solid ice in the ground or vapor in the air, not as a liquid on the surface. You might see some fine wispy clouds high in the sky, but don't bother bringing an umbrella. The whole planet is drier than the dustiest desert on Earth. and there hasn't been a drop of rain here for millions, perhaps billions of years.
The thing that fascinated me was that we could see valleys snaking across the surface that had clearly been carved by flowing water. So this is telling us that in the past it was different, and not only that, it was different in a way that would have made it more suitable for life than it is today, and that I found truly compelling.
We are very convinced that at one time it was a very hospitable planet with liquid water and enough atmosphere to sustain a climate. And so now we're trying to understand, how did it change, why did it change, and what still might be on Mars.
These are deep Martian mysteries. If Mars and Earth started as sister planets, did life once festoon the Martian surface? Might it still be there? And where did all the atmosphere and water go? Solving these puzzles has challenged our planetary explorers from the moment the first Martian postcards were sent back to Earth.
It's the fact that it is so much like Earth that kind of makes Mars such a special place.
Steve Squire's Martian Odyssey has taken him from pole to pole, visiting those places on Earth that share at least some of the same characteristics. They are extremely dry, extremely cold, or extremely dead. Death Valley is one of his favorites.
This is actually a really important place. It's a place we call Mars Hill. We first found this place about 20 years ago. In those days, the only successful landings that had taken place on Mars were the 2 Viking landers. And they landed in places that looked very much like this.
In order to plan for the current Mars mission and to test the cameras and other equipment, NASA needed a good Mars look-alike. They found it at Mars Hill.
To your eyes, the main way in which Mars would look different from this scene would be the color. The color of the sky, and the color of the rocks, and the color of the soil. The colors on Mars are painted from a very narrow palette.
The color palette here is based on rust, rich in iron oxides. The rocks and soil and the rusty dust are always blowing around in the freeze-dried atmosphere. You won't see any blue skies in the tourist brochures for Mars. Instead, they're amber. Not only do the dust particles add a rosy blush to the sky, they also scatter sunlight in a way that turns the color of the Martian sky upside down to human eyes. Red by day, and blue at dawn and dusk. This is a sunset as seen by Spirit, a cold blue sun dropping over a distant alien horizon. Looking up into the clear, starry skies from the surface, you would see Mars's 2 tiny moons, Phobos and the smaller Deimos. With all the grace of a space potato and barely 17 miles long, Phobos has been targeted as a potential stepping stone for the first human mission to Mars. A test run before attempting the fuel-hungry and risky trip to the planet below. Dreaming about Mars and actually going there are 2 very different things. Mars may be our neighbor, but 35 million miles to the closest point is still a very long way from home.
To put humans on the surface of Mars, someone once joked there are only 3 issues: getting them there, keeping them alive while they're there, and getting them back.
That's a good step. Yeah.
Our space-age dreams of off-world colonies on the Moon and Mars faded with the cancellation of the Apollo program and the last trip to the lunar surface in 1972. It didn't stop us from traveling. We simply switched from astronauts to lower cost, lower risk robotic explorers. And when it comes to Mars, it's probably just as well.
Getting to Mars is just unbelievably hard. We've learned that the hard way. Before, certainly if you go back to the days before the rovers launched, 2/3 of the missions that have been flown to Mars had failed. And they failed for all kinds of reasons. Rockets that blew up and spacecraft that just vanished hardly without a trace.
In fact, landing on Mars has always been hit or miss. But so has blasting off from Earth at exactly the right time.
The right time to go to Mars, basically the only time to go to Mars, is when Earth and Mars are properly aligned with one another. You have to wait for them to get into just the right position to go from point A to point B. And you've got to be on the launch pad ready to go when that launch window is open. And if you miss your opportunity, you don't get to try again for 26 months.
5, 4, 3, 2, 1, engine start. Liftoff of the planet Mars.
If you are ever lucky enough to book a flight on the first rocket to the Red Planet, you'd better be sure you've packed everything. The one-way trip is at least 6 months, with no turning back if you've forgotten something.
We can go to the moon and get back in a week. It takes about 3 years to go to Mars and come back. You have to carry your food, you have to recycle your breathing oxygen and your water. So it's a very, very major undertaking. Within about 3 days, the Earth looks very small, and within a week, it's just another star. And you suddenly are going to realize you're in very deep space, and it's going to be a long time before you can go back.
Before we take this giant leap, we need to be able to carry everything needed for a 3-year round trip with us. This is a much larger effort than getting to the moon. It's the Apollo mission on steroids.
At this point, we know at least as much as the engineers knew at the time that they agreed to land on the moon. And they had only 9 years, so I think once the nation decides they really want to land humans on Mars, the system can be designed and developed and built.
Fast forward to the future. After 6 months crossing the blackness of space, things suddenly get a lot more interesting. The combination of a high approach speed, a thin atmosphere, and twice the gravity of the moon makes Mars one of the hardest places to land in the solar system, even for robots.
You hit the top of the Martian atmosphere, you go on Mach 27. 27 times the speed of sound. And for our vehicles, between when we hit the top of the Martian atmosphere and when we were bouncing on the surface with the airbags was 6 minutes. It's a hell of a ride. You use a heat shield to slow you down to a leisurely Mach 2, twice the speed of sound, and then we throw out a supersonic parachute.
Everything is complex, and everything has to happen precisely on time.
The worst part is when you come into contact with the Martian surface. There's no runway, okay? There's no nice place to land. And you can't control very well where you're going to come down. So you're going to come down in a field of rocks like this. How do you guarantee that your $1 billion spacecraft is actually going to survive that? The approach that worked for us with our rovers was great big airbags. Bounce, 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 bounce. Finally, the vehicle comes to rest. Vikings used rocket motors, and they just touched down gently on the surface, and they were fortunate. It was just good luck. They landed in a field of boulders like this, but they didn't land with one that was poking through the belly, and it all worked. You have to be good, and you have to be lucky.
A safe arrival is your passport to a dangerous new world. This is a planet where the atmosphere is your enemy, and even the dust is dangerous. Want to step outside to take in the scenery or pick up some rocks? As familiar as it might look beyond the porthole, Mars is dangerously alien. The upside is that the low gravity will give you super jumping abilities. The down, the almost complete lack of an atmosphere. This is not home. There is nothing here to breathe. To find similar conditions of low temperature and pressure on Earth, you have to travel 3 times higher than a commercial airplane, to the very edge of space. Planetary scientist Bob Brown shows why you should keep your helmet on when visiting Mars.
We have this, just a beaker full of water. We're going to put it in this little chamber. And attach a vacuum hose to the chamber and pull the air out of the chamber.
As the pressure drops to Martian levels, the water boils at room temperature.
So if you were to take your helmet off on Mars, the liquid in your face especially would start to boil, and much the same as this liquid water started to boil, and I guess I don't have to describe what that might feel like or what it might look like.
A medical travel advisory might say to keep your suit tightly fitted, but so far, no one's built a suit that'll work on Mars. Existing spacesuits are simply too bulky, too heavy, and too complicated to wear for the sort of regular activity required on the unforgiving surface of Mars. Like Steve Squires, planetary scientist Chris McKay roams the remote Mars-like regions of Earth. Here, in Australia's arid Flinders Ranges, he hunts for the extreme ways of living that we might find on Mars. Organisms like the bacteria that makes the green smudge inside these white desert stones.
If I was trying to do on Mars what I'm doing here, the biggest problem would be a suit that I could use to go outside. Something we take for granted here. I get up in the morning, I put on a shirt and a pair of jeans, and out I go. So it's got to be routine, easy to use. Many times I've been working out in the field in the Antarctic or the Arctic, and I just have to take the gloves off because I'm doing something that requires that quintessential human capability of touch and feel and hold. So my request to the engineers is give me a spacesuit with gloves that'll keep me warm and keep me pressurized, but still allow me to use my hands.
Not only will you want to move your fingers, you'll want to move around. NASA's Lunar Electric Rover is a prototype for future missions to the Moon and Mars. It's part vehicle and part spacesuit.
I can just picture being there in a vehicle of this type and looking back at Earth in the distance and deciding to go EVA and being boots on the surface in 10 minutes, which would just be a remarkable breakthrough.
Astronauts can cover more ground by living in the vehicle for weeks at a time, stepping outside when they want to, and back inside at the first sign of danger.
Mars does not have a powerful magnetic field the way Earth does. So there's radiation from the sun, also cosmic rays that are going to penetrate through spacesuits.
An astronaut might get a 30-minute warning of an incoming solar storm, but less predictable is the risk of being hit by a meteorite. Recent estimates based on fresh crater counts suggest that up to 200 new holes are blasted into the surface of Mars each year. And even the Martian moons are not guaranteed to stay in place. The days of Phobos are numbered. Possibly an asteroid that once strayed too close, the moon is trapped in a fatal gravitational embrace. Every passing century sees it drop 6 feet closer to death. In about 50 million years, its fall is expected to be complete. The aftermath, if anyone is around to see it, could be Mars with a bright ring of moon dust to rival Saturn's. But events like this are not your real danger. It's the day-to-day exposure to the cold, dry Martian environment that will make a long stay tricky.
It was 119 degrees Fahrenheit here yesterday. Really, really, really hot day on Mars. It'll get up to about 30 degrees Fahrenheit, and at night, it goes to more than 100 below.
Martian deserts are both frozen and sun-baked. With no ozone layer, UV levels are so high that any unprotected organism, even a Martian microbe, will be burnt to a crisp within minutes. A good hat is just not going to cut it. So why not leave all the dirty work of exploring Mars to robots?
One thing about humans is that they have a capability to improvise on the spot, even if you don't have the right tools with you, that robots lack. In Death Valley, this stuff was wet, it got dry. When it dried, it cracked. We're investigating the idea that something similar happened on Mars. You know, I'd love to be able to do this on Mars, and we can't. You know, human on the scene can improvise pretty well.
Getting down and dirty on Mars will mean exactly that. Moon dust caused enough problems for the Apollo astronauts, without an atmosphere to blow it around. On Mars, dust is going to be a serious problem.
Mars is a dusty place. In fact, it's a lot worse than this. When you think Martian dust, you shouldn't think sand. It's more like cigarette smoke. Very, very fine-grained stuff, and it gets everywhere. Coats everything. People are going to breathe it in. It's going to get into the habitats. It's going to get on people's spacesuits and their clothing. It's going to be a real challenge, and I think they're going to have to devote a lot of effort to finding ways to deal with that dust, because it's horrible stuff.
When an ill wind blows on the red planet, dust really does go everywhere. About once every 3 years, local storms go global, and the dust can block your view for months. It happened the very first time we sent a probe into orbit in 1971.
When Mariner 9 got to the planet, there was a giant dust storm that had completely shrouded the surface from it.
They could see nothing, just dust. And as the dust started to recede, all of a sudden these dots appeared. There's 3 of them lined up. What the heck are those? Turned out to be the peaks of the 3 great volcanoes on Mars.
And that's when we began to realize just how varied the terrain and topography of Mars was.
This was the moment that Mars began to reveal itself. A world with a secret history and the spectacular scenery to match. Tired of the Earth's scenic sights? The Himalayas not high enough? The Grand Canyon too small? Try the Red Planet for sightseeing on an enormous scale. Thanks to our sharp-eyed spacecraft, Mars is opening up like never before. These are real landscapes that humans will one day marvel at in person.
You know, if you're going to Mars, you'd want to go for the scenery, right? I mean, you're not going for the culture. You're not going for the climate. So you definitely want to go for the scenery. One thing that people forget is that when we've landed on Mars, we have to go to places that are safe, and safe equals pretty smooth and flat. There are places where the scenery on Mars is just breathtaking.
Here's a bit of Mars that's anything but smooth and flat. the magnificent Valles Marineris. This titanic canyon system, over 2,500 miles long and 6 miles deep, is probably the grandest geological feature in the solar system. It's clearly the red planet's must-see destination.
As a human being, it's the sheer gigantism of Mars that is amazing. The Valles Marineris beats the Grand Canyon hollow, and if you've ever seen the Grand Canyon, you will never forget it.
It's so colossal, the Grand Canyon would be easily swallowed by one of the smaller side branches.
We're talking about something here that's the width of the United States or of Australia across here.
So I think the Valles Marineris would be the place to go. I mean, build a lodge right on the rim so you can look in.
The attraction goes beyond sheer scenic splendor. Deeper than the canyon itself is the mystery surrounding its formation. This giant fissure, once filled by mighty lakes, has been scoured by floods of biblical proportions.
You can make estimates of how much water had to have been flowing to carve these things, and you get numbers like 100, 200 Amazon rivers all cutting loose at once. I mean, big, big amounts of water flowing across the surface.
The other big attraction on Mars is the largest volcano and highest mountain in the solar system. Olympus Mons towers at an astounding 17 miles, 3 times higher than Everest. Its base covers more ground than the United Kingdom, and the massive caldera at its summit could easily swallow Greater London, Paris, and New York.
So things tend to be big on Mars. I think in part that's because the planet has lower gravity. And so when you pile up lava, you can pile it 3 times higher because the gravity is 3 times less before it'll start to collapse under its own weight.
Mars is a far more active world than previously thought. We see landslides of dust and gullies freshly carved by outflows of mysterious fluid. And this peculiar region has been claimed as a flash-frozen sea, complete with fossil icebergs. Likewise, there are glaciers, geologically recent, but now buried beneath a protective blanket of dust, waiting for the next change in climate. Still, most of the defining surface features of Mars were carved way back in the good old days.
Certainly, something happened in the early history of Mars that led to great releases of water. And of course, people wonder, with that much water, could there have been ancient oceans? Could there have been environments that were very much like life environments on the early Earth?
Early Mars was a different world. A world with a thicker atmosphere, with weather and water, possibly a vast, shallow northern ocean. This was really the time to go to Mars, when you didn't need a spacesuit. Perhaps just an oxygen tank and some warm clothes.
When we reconstruct in our imaginations Mars of 3 billion years ago, we tend to make it like Earth, warm and cozy, but it wasn't. Mars, back in its wettest, warmest phase, was probably like Earth today in its coldest regions. So I'm imagining a place where the snow and ice is melting in the summer to form transient ponds and streams and ice-covered lakes. It's cold, it's wet, but it could be rich with life.
This is the Mars that we want our astronauts to get their hands on, to bring back and study. The wet Mars of old, where we might find the evidence of life. The fourth rock from the sun has always had a special card to play, the chance of meeting Martians. And in recent years, the odds of a close encounter have been steadily improving. If you want to find life on Mars, First, you need to find water. And not all of the planet's water story is ancient history. There's been plenty of frozen underground evidence detected from orbit, but scientists needed to touch and taste it to be sure. In 2008, they finally got their opportunity when NASA's Phoenix lander made a daring approach to the high Martian Arctic.
60 meters. Coordinate sequence initiated.
There was not ever more excitement in my life than landing safely on Mars. I've been through the opposite. I've been through a landing that was not successful, and I did not want that to happen again.
The landing was not only perfect, but the engines exposed suspicious white patches directly underneath the spacecraft. Water ice was just a few scrapes away.
We did find water ice, and we found that the soil in connection to it has calcium carbonate, a compound that forms in the presence of liquid water. If it had been wet, then we wanted to look for nutrients and food sources that could support microbes.
The water ice is proof of a valuable resource for any life form still clinging beneath the surface, and for future travelers.
We now know that these plains that you see stretching behind me are underlain only 2 or 3 inches deep by a sheet of ice, all the way as far as you can see. Great hockey rink if you had a hockey team on Mars. All you need is a broom.
The possibility of running into Martians received another boost from a very Mars-like part of our own planet, Chile's extraordinary Atacama Desert.
The Atacama is special because it is just so profoundly dry. Speaking roughly, it's 50 times drier than Death Valley. It is deader than Death Valley. It's the only place on Earth where a Viking could have landed and searched for life and dirt on Earth and not found it, and instead found a reactive mixture of chemicals. The only place. We can take a small step into Mars. We can test ourselves. If we can't find the life in the dry core of the Atacama Desert, we're not ready to go to Mars.
Perhaps we are ready. Because even here, in the driest corner of the driest desert on Earth, life has confounded scientists. Cyanobacteria have been found living inside the rock-hard salt of a long-gone lake.
This is a halite, it's a sodium chloride salt, which is colonized by cyanobacteria. It's dark green because they have this particular pigment protecting them from the excess of UV light.
Once in a blue moon, a fleeting early morning ground fog delivers some rare humidity to the air above the desert. This precious moisture is greedily sucked into the microscopic pores of the water-hungry rock salt.
This is a very rare event. So these bacteria are living in an environment where liquid water is available a few hours during 1 year. Very, very hard.
If we're looking for Martian bugs, we should search for life forms at least as tough and alien as this.
I'm looking at Mars from the point of view of a microbe. And as a microbe, I really need a very, very tiny amount of water. I could probably live my entire life happily in a tiny drop of water about the size of the point of a pen. Now, we've shown over the years that organisms that live in salt crusts on the Earth have enough sunlight coming in so that they can go through their day-to-day activities but still be protected from the radiation. And we know there's salt crusts on Mars.
Scientists are gathering clues about where on the Martian surface you should land to have the best chance of meeting the neighbors.
In terms of current habitability, I think the most interesting place on Mars is right where the Phoenix lander sat. And that ice will be warmed when Mars is tilted toward the sun, which occurred as recently as 5 million years ago. That ice would have been warmed and wet, maybe even swampy.
Mars has a long-term wobble to its orbit, and every 5 million years or so, the poles end up tilting 45 degrees toward the sun.
A way of thinking about the Phoenix landing site is think about the polar regions on Earth. Imagine you're there in winter. It's very inhospitable, very cold, very alien. You think, how can anything survive here? Come back 6 months later, and it's like a different world. The sun is shining, it's wet, it's warm, things are alive and scurrying around. So we may be being misled, seeing this frozen, cold site, and in fact, we're just there at the wrong season.
We know that on Earth, some bacteria can survive being frozen for millions of years. They can also eat perchlorate, the highly reactive chemical Phoenix found in the Martian soil.
Presumably, if there was life at the Phoenix site, it had learned the same trick. And so there might be organisms that are literally eating the rocks and reacting with perchlorate below the surface, shielded from the ultraviolet light, just having a great old time 5 million years ago. The party is over because everybody froze, but another 5 million years, the party will start up again as the Martian summer comes to the North Polar regions and the ice turns to water.
The party might not be over everywhere. The gas methane has been found both by spacecraft in orbit and by telescopes from Earth. It's chemically impossible for methane to survive for long in the Martian atmosphere, so it must have been released recently.
Now, what makes methane? Cows make methane. It's probably not cows. Microbes of various sorts can release methane. There are a variety of geologic processes. Volcanoes can release methane. So the mere fact that there's methane doesn't say life. But either way, the methane says that Mars is an active planet. It's either biologically active or it's geologically active, or both.
The methane release appears to be seasonal and linked to areas of suspected subsurface ice. Ice found exposed in fresh craters has proven that water lurks not only near the poles, but also much closer to the equator. It's pretty clear that if the Viking landers had dug just 4 inches deeper, they would have reached this ice, and perhaps a totally different conclusion about life on the red planet.
So if Mars has any life at all, whether it is so small you can only see it with a microscope, or if they had a mammoth, it wouldn't matter to me. It's the whole question of, is there life at all on Mars?
Either way, there certainly will be life on Mars the moment the first human traveler arrives. The fact that there are no scheduled flights to Mars hasn't stopped people from preparing for the trip. And for a flight like this, planning is everything.
And there we go.
In 2009, 6 men walked into a series of connected rooms inside a warehouse in the Moscow suburbs and shut the door behind them for 3 months. They took all their food with them and drank recycled water. The only communication with the outside world was electronic, with a 20-minute delay. They were trying to simulate a flight to Mars.
You've got to think about what it's going to do to a crew to be cooped up in a small environment, but for that huge period of time, they're going to be the first people in the history of their species to travel that great distance, to be so far from home where they can't even have a normal telephone conversation with their family, with their friends. So we shouldn't underestimate what psychological problems might do for them.
There is no room to screw up on a trip like this, mental or otherwise. Once on Mars, you are likely to be stuck there for a year or more, waiting for a window of opportunity to ride home. And unlike a robot, the hopes and fears of the whole planet will be riding with you.
I think that humans are going to do a better job of exploring Mars ultimately than robots ever can. Robots move really slowly. Okay, what Spirit and Opportunity have done in 5 years on Mars, 2 astronauts could probably have done in a week.
As fast and as smart as we are, we still need mechanical help to scout the course for Mars. The next robot rolling on to red dirt will be aptly named Curiosity.
It's the size of a small car, and it has a nuclear power source, so you don't have to worry about dust accumulating on solar arrays or anything like that. And most importantly, it has the capability to look for trace quantities of organic molecules. So we've gone beyond now looking for evidence of habitability to actually looking for evidence of the building blocks of life.
Whether it's alive or dead, a trip to this red planet has a lot to teach us about our lonely blue one and the universe beyond.
Now, if you have 2 planets that are next to each other in the same solar system that both had independent origins of life, you would have to conclude that the chance of having life all over the universe, indeed, even in other places in our solar system, would be very high. I think, you could basically go to the bank and bet on it.
We're not going to Mars just to search for life. We're going to Mars to search for a second genesis of life. We'd like to find something that's different from us, that doesn't have the same genetic history and genetic code that we have. And from my point of view, the more alien, the better.
Now, the second possibility is that we find life on Mars, but my goodness, it has a genetic code exactly like us. It uses DNA. It's too coincidental. This is representing our cousins. Life either arose on Earth and went to Mars, or actually more likely, that life originated on Mars and it was transported on a meteorite or a comet to the Earth early on, and in fact, our home planet is Mars.
So in some ways, a voyage to Mars could be a voyage home. Our ancestors have made such bold trips before. When we walked out of Africa, when we sailed over the horizon. If it's technically possible, our ships will head out again.
We've always wanted to see what's over the next hill, and Mars is that next over the hill. Sure, you're going to have to be in a suit, you're going to have a habitat, but it's a solid planet. It's got a surface. You can see, you can work, you can explore.
I've thought for about 30 years now that we could go to Mars. And usually when people ask me how long it would take, I say 15 years because we've been saying 15 years for the last about 4 decades.
Oh, a human mission to Mars can't happen soon enough for me. I'm a robot guy. Okay, that's what I do with my career, is build robots and send them to Mars. But I also think that we send things to Mars for reasons other than science. Our rovers, Spirit and Opportunity, were built by people who, like me, grew up in the 60s watching Mercury, Gemini, Apollo on TV as little kids and dreaming of sending spaceships to Mars someday. And now we do. And I think as people watch the first human explorers on the surface of Mars, they are going to be similarly inspired to do things that I can't even imagine at this point. It's going to be very costly. It's going to be dangerous. But I think it's something I'd certainly like to see happen. I'd love to see boot prints in our wheel tracks. I would love to see boot prints on Mars.
When the first human footprint is made on Mars, it will represent more than a giant stride into space. This one small impression will be proof that humanity is once again on the move. Travelers once more moving beyond our comfort zone to explore new lands and new opportunities And have no doubt, there are many worlds out there ripe for exploration.